We're asked to compare three compounds: ethanol, propane, and acetone. You can tell by the electrostatic potential diagrams that ethanol and acetone are both polar molecules, whereas propane is nonpolar. The question is asking us to rank from lowest to highest the boiling points of these substances. In order to do that, we have to understand what boiling point is. The boiling point of a substance is the temperature where the vapor pressure of the liquid equals the external pressure above the liquid. Oftentimes, this is the atmospheric pressure. If we consider the external pressure to be the same for all these substances, we can answer this question by ranking the vapor pressures of these liquids. Remember, intermolecular forces of a substance will tell you about the vapor pressure of that substance. And since none of these are ionic compounds, we're going to consider hydrogen bonds first, followed by dipole forces, followed by London dispersion forces. London dispersion forces are primarily determined by the size of the molecule, and all three of these molecules have roughly about the same size. So let's start by seeing if any of these substances have any hydrogen bonding opportunities. You can see ethanol has a hydrogen directly covalently bonded to an oxygen. That's an area that can participate in hydrogen bonding. Now be careful, some students will simply see a hydrogen and an oxygen anywhere in the molecule and think it can form hydrogen bonds. Now that's not correct. Acetone cannot form hydrogen bonds with other acetone molecules. Since ethanol has the strongest intermolecular force because it has hydrogen bonding opportunities as well as the London dispersion forces, ethanol has the highest intermolecular force. Because of that, it's going to have a low vapor pressure because it's going to tend to remain as a liquid. And therefore, it's going to require the most thermal energy to bring this vapor pressure to match the external pressure. In other words, it's going to have the highest boiling point. Next, let's move over to acetone. Acetone does have a polar bond between the oxygen and the carbon. And because of that polar bond, this molecule is polar. And therefore, it can participate in dipole interactions with other acetone molecules. In addition, it has London dispersion forces. Acetone has the next highest intermolecular force. Therefore, it has the next highest boiling point. Finally, let's take a look at propane. It's a nonpolar molecule, so the only intermolecular forces propane has are London dispersion forces. And again, all three of these are relatively the same size, so they all have about the same London dispersion forces. So propane has the weakest intermolecular forces, which means it's going to vaporize easier than the other two compounds. It's going to have the highest vapor pressure, and therefore, it's going to be the easiest to boil because it wants to vaporize more than the others, you can say. So it's going to have the lowest boiling point. So here's your answer to this problem. Propane, having the weakest intermolecular forces, is going to have the lowest boiling point, followed by acetone, followed by ethanol. Ethanol will have the highest boiling point because it has the strongest intermolecular forces, keeping those molecules together.